Howdy. Today's video will focus on the standard form of the quadratic equation, as well as two more transformations. Yes, we were not done yet. Alright, so the two more transformations, we have, looking at this graph here, we have the graph 2x squared, and you're probably saying that it doesn't look much different from the parent function. But looking at our points, our parent function points would have been at 0, 0, 1, 1, 2, 4, and 3, 9. But the points of this graph are at 1, 2, and 2, 8, and our third one would have been at 3, 18. Okay, so what does that tell us? That pretty much tells us that these points are double that of our parent function. So that is 2x squared is 2 times f of x, where f of x was our parent function x squared, the quadratic parent function. And we multiplied a 2 to the outside of the quadratic parent function, f of x equals x squared. Thus, we pretty much stretched our graph upwards. It's an elongated version of our parent function. Okay? So pretty much we can stretch it, or we can compress our graph. We can also, if we multiply our parent function by 1/2, so 1/2 f of x, that would have brought our points down by half. So it would have been here. 2, 4 would have been 2, 2, and 3, 9 would have been 3, 4.5. So it would have been right there. Okay. So in order to stretch the function, multiply by a whole number outside the function. Therefore, if we have b times f of x, that is f of x stretched by a factor of b units. To compress the function, multiply by a fraction outside the function. Therefore, a divided by b times f of x is f of x compressed by a factor of a divided by b units. Now, moving on to standard form. This here is the standard form of an equation for our quadratic equation. And this creates a parabola on the graph. Alright, parabola is just that U shape. Okay? So, we need to graph the equation to find the following things: axis of symmetry, vertex, and our roots. Our roots are the solutions to the quadratic equation. Those would be wherever they cross the x-axis. Okay? And then the vertex is the highest or lowest point on the parabola. So this would be our lowest point here, our lowest possible point. And if we had an upside down parabola, this would be a vertex. And it determines the graph to be a minimum or maximum. So if we had a right side up parabola, then this would be called a minimum parabola. And this one, it's upside down, it would be called a maximum parabola, since the highest point is on top of the parabola. And then also the axis of symmetry. That is the line that divides the graph into two perfect halves. So if we had our parabola, then this line here would be our axis of symmetry. Okay, now moving on. One of our two examples, our axis of symmetry. Let's find that of this graph here, and that would be right here, our axis of symmetry, and that is the point x equals -2. So we're going to put x equals -2. Then is it a min or max? Well, we have our point here at the very bottom of our parabola, so it would be called a minimum. Our vertex is that point that we just circled, and that would be -2, -1. And our roots would be here and here. So that would be -3, 0, and -1, 0. Okay, now, second example. Let me get a different color, because that black didn't really show up. Alright, so our axis of symmetry, it is whatever splits our graph into two perfect halves. So that would be right here. And that is the number 4. So we would put x equals 4. Now, is it a minimum or maximum? our highest point on our graph is right here. It's at the top of our parabola, so this would be called a maximum. So max. And then our vertex is that same point right here, so that would be the point 4, 8. And the roots would be whatever whatever points that are crossing the x-axis of our parabola. So this point and this point. Our first point is 0, 0. And our second point is 0, 8. Alright. And that's it for this video, people. It was pretty short, pretty simple. I'm sure y'all have 5 minutes to spare in your busy schedules of eat, sleep, go to school. But, alright, cool beans, guys. Thanks for watching. See y'all in class.